My name is Marcus Morris, and for my GT4801 final project, I'll be going over the analysis of world carbon dioxide emissions and energy usage trends. The dataset was sourced from Kaggle.com, with columns including a collection of key variables associated with a country's energy production around the world, including the country's name, the types of energy produced by those countries, the individual carbon dioxide emissions for each energy generation type, along with the energy consumption and production for the individual energy generation types, and then the overall country GDP, population, and energy intensity per capita and by GDP. The data is overall analyzed on an annual basis from 1980 to 2019, with data sourced from 190 plus countries. The data is structured in a CDV file with all data sourced from the U.S. Energy Administration. The overall research question for the project is how do carbon dioxide emissions correlate with a country's other information, including their energy use patterns? So that includes consumption, production, the energy type, and intensity, as well as the country's GDP and population. This specifically, we'll be taking a deep dive on the energy use patterns and how the type of energy source is going to be correlated with those CO2 emissions. So coding methodology can be broken down to three distinct categories. The first one being statistical analysis, which was done using the built-in .core function. Visualization was then generated with a heat map using the Seaborn library. Next, global emissions and energy trends were visualized with a bar and line chart using the Plotly library. And finally, we looked at the data structural hierarchy using a series of sunbursts, once again with the help of the Plotly library. So here's our first figure, which shows the world carbon dioxide emissions and energy usage, and how these different columns are correlated. So we focus in on this last row that has the carbon dioxide emissions. We'll see what first stands out is the strong positive correlation with energy consumption and production. This is to be expected as energy consumption is growing. As long as those energy sources are what I'll be defining as dirty or have high carbon dioxide emissions will increase. Similarly, we have GDP, population, and year showing the same positive correlation, although to a lesser extent. So what this shows us is that over time, countries are increasing their GDP and increasing in population, which of course leads to an increase in energy demand, which is giving rise to our CO2 emissions. To a lesser extent, we also see a positive correlation with energy intensity per capita. So, as well as a fairly strong negative correlation with energy intensity by GDP. What I believe this may indicate is although energy intensity is positively correlated with CO2 emissions, there has been some growth in energy efficiency indicated by the negative correlation value with energy intensity by GDP. So the richer nations are finding ways to increase their energy use and production while keeping CO2 emissions relatively down, however not to a large extent. For further analysis, I'll be taking a deeper dive in energy consumption and production, as those two variables have the strongest correlation. This leads to our second figure, which shows world generation by source versus our CO2 emissions. So the first aspect of this figure is the energy production, represented by the side-by-side bars, which show energy production over time and broken down by source. Then to our right, on this y-axis, we have the carbon dioxide emissions over time, measured in the following units. So from this figure, we are seeing that high emission energy generation, that dirty energy that I mentioned, is increasing over time and are significantly making up the energy or the world energy generation. Those sources being namely oil, gas, and coal. So although renewable energy generation has been growing, represented by these green bars, it's not been enough to counteract the effects of all of the fossil fuel intensive energy sources that are driving up the carbon dioxide emissions. We can further take a look at this breakdown by using the sunburst charts. So here we are seeing that clean energy is slowly growing over time. Here's making up a lesser percent of the total energy until it's reaching its where it is right now, being around maybe 18 or 20%. Something interesting to see here is that there's initial growth in nuclear along with renewable, but in the past 2 decades it has decreased, mostly over the high expenses of nuclear energy and also the general fear and low public approval of nuclear energy. So most of the clean energy growth is being seen with renewable sources such as solar, wind, and hydro. However, we are seeing that dirty or fossil fuel intensive energy is dominating the world energy generation breakdown, with oil decreasing in its percentage over time, with that being compensated by an increase in gas and a slight increase in coal. Overall, if we are going to see a decrease in emissions, we'll need to significantly decrease the amount of generation that is done by fossil fuels and increase our clean energy usage. Thank you for listening. These are my the following are my sources for this project. And once again, thank you for listening and I hope you have a great day.